Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CIPAT, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we are going to see about the advanced concepts in object-oriented programming that include the concept of friend functions and friend class, the this pointer usage and virtual functions. So, first we will see about the concept of using the keyword friend. So, what are the points to be noted while using the friend functions and in what situations and application programs these functions are used? These functions are not members of the class. For example, when we want a certain task to be done by a particular function which is not a member of the class, we declare them to be friend functions. So, these functions, though they are not declared within the class, yet they give access to the class's private and protected members. So, private and protected are nothing but access specifiers of a class. Generally, only those functions which are declared within a class can be accessed by the objects of that particular class. Another class cannot even see them, but when we want exceptional situations where another class should be able to see the private and protected members of a friend class, we can use this keyword friend. They are general external functions that possess special access privileges. So, as the name suggests, they are external to the class, outside the class, yet they have access to the class's private and protected members. Generally, only the functions within a class will have the access, but friend functions are exceptional cases where though they are outside the class, they can access the private and protected members of the class. They are not called using the member access operators. Normally, we use object name dot function name to access a particular function, or when we are using pointers, we use the arrow mark, but these functions are not called using both these methods. Friend function is declared by the class that grants access. So, the class which wants to give access to a function which is declared outside it only should declare it to be a friend. Another class cannot declare. One particular class should be willing to expose its members to another function which is outside it. Only that class has the right to give this privilege. Declaration can be placed anywhere in the class declaration. So, anywhere inside the class the declaration can be there. It is not necessary that it has to come right at the beginning like we are declaring the variables and other functions. The friend function can be declared anywhere inside a class. This is not affected by the access control keywords. So, whether you call it private or public or protected, these friend functions alone are not affected by any of these. And these friend functions in certain cases can be accessed by the member access operators dot and arrow mark only when they belong to another class. There may be certain functions which are global in nature, they are not declared within another class. Those functions are not accessed by these operators. Only when these friend functions are members of another class are they accessed by these member access operators. So, these rules are to be followed when we are using friend functions in C++. Then we have a friend class. It is not necessary that only a function needs to be a friend. Even an external class, another class in the same program can be allowed to access the friend class's private and protected members. So, when a class is declared to be the friend of another class, it is called the friend class. When a class is declared as a friend, all its functions also become the members of the other class. So, when a class is declared to be a friend, all the member functions of that friend class become the members of this particular class. The class that becomes a friend must first be declared, forward declaration. So, when you are declaring a particular class to be a friend of another class, first you should know what all is available in that particular friend class, otherwise what is the point in declaring it to be a friend. When you declare another class to be a friend of a particular class, what are the availabilities in that friend class, what functions are available, in what way it is useful for this particular class is to be known. So, that is the reason that class must first be declared. We should first know what are the data members available in the class, what are the functions in the class, what that class has the capacity to do. Only then we can declare it to be a friend of a particular class. So, that is called forward declaration, declaring prior to becoming a friend. Now, what are the basic features in these? The friend of a class can be the member of another class. So, it is not necessary that friends have to be independent. they can be belonging to another class, at the same time be a friend of a different class. Friend of one class can also be the friend of another class or all the classes in the program. So, one class can have many friends, it can be the friends of many classes in the program. A case in which a particular class or a particular function is a friend of all the classes in the program, that is called a global friend, like it is available to all the classes in that particular program or application. Friends are non-members of the class. See, when you are having a particular function in your own class, you need not make it your friend at all, because already you have access to that function and that function has access to the data members. Only when a function is not a member of a particular class will you be interested in becoming a friend. So, this is a common concept. When we write programs, sometimes we forget these basic concepts. When a particular function is in your own class, you do not need to become its friend. Only when the function is external to a class is there any point in making it a friend. So, generally friends are non-members of a particular class, and friendship is not transitive. For example, say you have 3 classes A, B and C, B might be a friend of A and B might also be a friend of C, but that does not mean that class A is a friend of class C. Only that particular class which is declared to be a friend is a friend of the class. If class B is a friend of A and class B is also a friend of C, does not mean that class A is a friend of C. The relationship does not continue from one class to another. Explicitly, when a particular class or function is declared to be a friend, only then it becomes a friend of a class. You cannot pass this relationship through intermediary classes. That is to be kept in mind. So, we will see an example of these friend functions and classes. We are having the header file, you are having a class first and you are having a class second. Now, see, this class second is being declared over here already. We are not declaring first, but we are declaring the second class. Here under public access specifier, we are having a display function void disp, and this disp is having an argument ampersand f. This is nothing but first is the name of this class. So, this f becomes the object of this class. So, here the object, rather the address, using this address operator, the object of this class is being passed as an argument to this function disp, which belongs to the class second. So, the second class will be able to access this first class's object only when the second class is declared as a friend. So, now we will see how that class is declared as a friend. So, here the second class gets over. We are closing this class over here. It is having only one function disp, and that function is having an object of the first class as its parameter. So, here we are declaring class first. So, because the second class has to become a friend of the first, that is the reason we are declaring it earlier, forward declaration, as we saw in the syntax or requirements for a friend class. So, this class first, it is having 2 integer variables of type private, because there is no access specifier here, the default specifier is private. We are having 2 integer variables x and y, and here we are declaring the second class's friend function disp. Friend void is the return type, second is the name of the class, scope resolution operator, disp is the name of the function and the argument. So, this particular function is said to be a friend of this class first. That is the reason this function is able to access the object of this first class. Then you are having the public access specifier, and this is a new statement that you are seeing in C++. This is another way of declaring or initializing the values of variables. We have seen about constructors, which are member functions which give initial values to variables. This is another way of declaring or defining a constructor. First is the name of the class. So, all constructors are having the name of the class as their function name. So, this is a constructor. When you give the syntax like this, the variable followed by a value and again a variable followed by a value, it means that this one is given to this x variable and this 2 is given to this y variable. So, x is holding the value 1 and y is holding the value 2, and then you have to give empty braces like this, which indicates that the function is over, and here you are completing the class. So, this is just another way of constructor declaration. You are initializing the values of these 2 variables x and y using the constructor function. So, now the program is clear. You are having 2 classes, second and first. second is having only one function called disp. That particular disp has been made a friend of this class first. So, now disp has access to all the members of the class first. Now, in this particular page we are seeing that the definition of the function disp, there we have only seen the declaration, we have not seen what the function is doing. So, here is where the function is being declared. You are having the return type, class name, scope resolution operator, name of the function and this argument. Now, here if you see Cout, the value of x is f dot x. Why you are having this f dot x? Because f is the object of this class first. Using the object only you are accessing the variable. From which class? From the class second with the function disp. This is because disp is a friend of the class first. And again the next step, using that f object you are accessing the variable y. So, here the values of these two variables will be displayed, but through the friend function of the second class. So, here you are having void main, here you are declaring first f1. This is the way to create an object. We know that when an object is created, immediately its constructor function is called. So, as soon as the compiler sees the statement, immediately the control will go to this particular constructor function. So, 1 will be given to x and 2 will be given to y. Then you are declaring an object for the second class, second S1. Then using this S1, you are calling the function disp, passing this object as a parameter. So, now this object will have the values of x and y, x is 1 and y is 2, and using that the control will go to this particular path and it will display the values. So, this is how the intermediary connection between the classes is established. This is quite a complicated concept because the same type of displaying we can do even without using the friend classes and friend functions. But in certain advanced complex applications, when you have to perform these kind of displaying values, you may have to create a number of objects and keep them in mind. Instead of that, when you simply have two classes, you create one object for each, and because you make them friends of each other, you can simply access all the member functions and member data members at your particular need. According to your need, you can just keep accessing them. You do not have to worry about whether it is public or private or protected. So, only to eliminate the limitations that are posed by these access specifiers, we go in for friend classes and functions. Once they become a friend, you do not have to bother about whether they are private or protected. Any data member, any function can access all the variables. So, only to give freedom for the user and the programmer to program the application easily, we go in for this friend classes and friend functions. Now, here we are going to see how the whole class becomes a friend. Last program we saw only the function. Now, how are we going to make the entire class become a friend of another class? The syntax is almost similar. We have class first, we are having class second as a friend of this class first. Again the same constructor, x is initialized to the value 0. We are having void disp, another function where we are displaying the value of x, and in private we are declaring this integer variable x. So, here we have declared class first, we have given a constructor initializing its values, and we are having a variable function to display that particular value. Next we go on for this class second. Class second is having only one function, that is calculate, CAL. It is having two arguments over here. One argument is first, which is having an object ampersand f. The other argument is integer y. So, this integer is a normal variable, a normal integer variable. This is nothing but an object. And here the similar example that we saw in the last program, this f is accessing the variable of the first class and assigning it a value y. So, again this class second, because it is a friend of the class first, is able to access that particular class's variable and is able to initialize it to another variable. So, this is the object and this is the variable. This is how you are accessing the variable of class first and initializing it to another variable y. Now, from the main function, how are we going to call these objects and functions? We will see that after the break. Welcome back after the break. Before the break, we had been seeing about the concept of friend classes. Now, in this program, we have seen about class first and class second, where class second is a friend of class first. We had initialized a value of a variable x to 0 in class first, and using the disp function in the class second, we are trying to access the variables of this class first and display it. So, here we are having the function void cal, which is having a object of type first as a parameter and a common integer variable y. So, from the main function now we will see how these functions are accessed. So, here we are having the main function first f1. So, here we are creating the object. So, when the object is created, immediately the constructor function will be called. So, as soon as the compiler sees this statement, it will pass control to this constructor function. So, here it will assign the value 0 to this variable x. Next we are coming to the second S1. Here we are creating an object for the class second. Second does not have any constructor, so no function will be called. Then we are calling this disp function of class first. Now, this disp function of class first is only going to display the value of x. Now, the value of x is only 0. So, that is why the first output is 0. Next we are calling this s1 dot cal f1 and 5. So, this f1 is the first argument which holds the value of the variable x as 0. This 5 is the value which is going to the variable y. Now, as soon as this function is called, the control will pass to that function. So, here this f is nothing but the object and this y will have the value 5, and this 5 is assigned to this variable x of class first. So, this is how friend classes are operated or executed in C++. Then again we are going into f1 dot disp. So, the first time f1 dot disp was called, x was initialized to the value 0. Now, after the cal function, x will be having the value 5. So, when the disp function is called the second time, the value of 5 will be displayed. So, that is how the output comes to 0 and 5. So, this is how from class second, using an object of class first, you are able to manipulate the variable that is present in the first class, only because the class second has been declared to be a friend of class first. Now, in this program you will see that class second has been declared only after class first. Normally we need to have a forward declaration. Class second needs to be declared prior to class first, so that class first will know what all capabilities it is acquiring when it makes second to be a friend of its own, and second will be able to see what all variables it has access to because it has become a friend of the class first. So, all these functions are only to the discretion of the programmer. He has to decide based on his discretion whatever application is in hand, whether the friend function is required in that particular application or not, because when we go into these higher concepts, there includes a lot of complexity in the program. Normally when people are reading the program newly for the first time, they will have to make a lot of marks about which friend belongs to which class and how they are having access. So, these concepts are to be used only for such programming paradigms and environment where their usage really has some advantage, like decreasing the time and performing the operations at a faster rate. This pointer is nothing but it points to another object, it holds the address of another variable. Now, what is this pointer? This points to the object for which the member function is called. For example, in certain programs a class may have many objects. All these objects will have access to the functions. So, at one particular point in the program we will not know which object is calling that particular function. So, when we want to know where the origin of this called function is, we can use this pointer. It will point to the object which made a call to this function. Friend functions do not have this pointer because they are non-members of a class. This pointer is only for the member functions of a class. So, when a particular object calls this friend function, we will not be able to identify from where that call has originated. So, that is a point to be noted with these friend functions. Next we go on to this concept of virtual functions. Virtual is something that does not exist in reality. It is something that people make it look as though it exists, but in actuality it is not present. This is needed to implement a different functionality in the derived class. So, this virtual functions mainly is implemented only with inheritance, like you have parent class and children class, you have a number of functions in those. When you want some function to have a different functionality, you go into these virtual functions. Normally a function will execute only one particular task, but when you want one function with the same name to have a different functionality, you go in for these virtual functions. They are member functions which are declared with the keyword virtual. Example is this: within a class you are having this virtual keyword, the return type, the function name and the arguments. This is the way to declare it. Now, what are the properties? virtual functions have their functionality overridden in the derived classes. Like virtual functions are actually declared in the base class only, but what that function is supposed to be doing is defined in the derived class. So, it is called method overriding. The same method has different functions in different subclasses. Function call is resolved at runtime. This is called dynamic binding. Static binding is during compilation itself we will know which object has called which function. So, the function will be executed then and there, and we will know how the function is going to have its result. Whereas in the case of dynamic binding, which object is calling that particular function is resolved only at runtime. So, based on the object which is calling the function and based on the class in which the function is defined, only when the function is executed we will actually know what functionality or what task that function really performed. So, this is only the effect of virtual functions in the program. So, now we will see an example of how these virtual functions are executed. You have draw, the name of the class, and here you are having the keyword public, you are having the keyword here virtual, the return type void, the name of the function area. So, this is called a virtual function which is declared in the base class called draw, and inside this base class you have an implementation given here, calculating area of figures. So, that is the functionality of this function area in the base class, and here the class is over, we are closing it with a semicolon. Here you are having class rect which is inheriting from class draw by the public mode of access specifying. In this class you are declaring keyword public, declaring the same function area. The same function area was declared to be virtual in the base class draw, but in the derived class rect this function is having a different functionality, area of rectangle, whereas in the previous function, that is in the base class, we saw that it displayed calculating area of figures, but in the derived class it is displaying area of rectangle. This possibility of giving a different implementation to the same function is only the concept of virtual functions. The function has the same return type void, it is having the same name area, and it is present in the base class, but in the base class it had a different functionality, and in the derived class it is displaying something else. It is not only in this derived class, in other classes also. Here you are having a class circle, this is also inheriting from class draw. Here again you are having the same function void area, but here it is displaying area of circle. So, in one class it is displaying area of circle, in another class it is displaying area of rectangle, and in the base class it is displaying area of figures. So, the same function is displaying different data based on the object which is calling that particular function. So, from main we will see how the different functions are called at different times. You are creating the objects for only one class. Draw is the base class, and you are creating 3 objects, 3 pointed objects for that class draw. Like you are having draw, pointer star D, pointer star D1 and pointer star D2. Then using this D you are creating new draw. We have already seen the importance of this new function. This is to allocate the memory space for the object which is created. Whenever we declare objects to be of this type, we have to use the new operator. So, this object D, using the new operator, you are pointing it to this function draw. This class draw is having this object D, for which you are allocating space using this new operator. Then using this pointer symbol, nothing but the member access operator, you are pointing it to this function area. Next object D1, you are creating the space for it using the class rect. So, now this D1 will point to the area function which is in class rect, that is why you are using this D1 pointing to area. Next you are having this object D2 which is being created for this class circle, and then using this D2 you are pointing to the area in the class D2 in the class circle. So, if you see 3 different objects for the same class, but you are making them point to different functions existing in different classes which are related by inheritance. So, that is a feature of these virtual functions. When a function is declared to be virtual, using the same function name, the same return type, the same arguments, you can give a different functionality each time that function is called. So, in this particular program, and how do you call the functions? Using the pointer objects, and by making those objects point to the particular function in that particular class. So, before you go into this D pointing to area, D1 pointing to area, you first have to declare this. Using the new operator, you have to first identify to which class this particular object belongs. Only then the particular function will be called, otherwise the compiler will not know which class's function is being called. Sometimes it may lead to an error, sometimes only the base class function will be called. So, we have to be very clear, before we make an object point to a function, we have to identify to which class that particular object belongs. So, this is the concept of virtual functions in C++. Next, we are having pure virtual functions. It is defined as a method that needs to be implemented by the derived class. So, in the case of normal virtual functions, we saw that in the base class itself, in the parent class itself, there was an implementation. But in the case of pure virtual functions, only the derived classes will have the implementation. The base class will not have any implementation. The derived class should not be an abstract class. So, whichever class is inheriting from the base class, it should not have a pure virtual function. Classes containing pure virtual function are called abstract classes. So, when you call a class to be an abstract type, that means that class contains a pure virtual function. So, how are these pure virtual functions declared? Abstract classes cannot be instantiated directly. So, a class which is having a pure virtual function, you cannot create an object for it, which is different from virtual functions. If a class is having a virtual function, you can create an object for that also. But in the case of this pure virtual function, you cannot create objects for that particular class. Only the derived classes can be instantiated. Instantiated means you can create objects for them, provided they contain the implementation for all the inherited pure virtual functions. So, when a class is inheriting from the class which is having a pure virtual function, it should provide an implementation for it. That means it should give a definition for that function, it should specify what that function is supposed to do. Not only for one function, but for all the inherited pure virtual functions, there has to be an implementation. Only then the derived class can be instantiated. You can create objects for it. Pure virtual functions have a signature, that is, they have an identity, they have a name, but they do not have any implementation. So, the declaration part of pure virtual functions, class abstract, in that you have the public access specify virtual void fun is equal to 0. Now, this is what actually specifies the pure virtual function. Virtual void fun, so far it is simply a virtual function, only when you equate it to 0 it becomes a pure virtual function. So, there will be no implementation for it, no definition for it, only the classes which inherit from this class abstract will give a definition for these pure virtual functions. The parent class which contains a pure virtual function is called the abstract base class. Now, suppose no class is inheriting from that particular class, it is called an abstract class. When another class is inheriting, it is called abstract base class. So, in today's session we have seen about friend functions, friend class, the this pointer, virtual functions and a variation of that called the pure virtual function. Explain the significance of the this pointer. As we all know, in member functions, the object which is calling that particular function, to point to it we use the this pointer. This cannot be applied in the case of friend functions because they are non-members of the class. What are virtual functions? Virtual functions are functions which have a different implementation in each class which defines it. So, with the same name, the same return type, the same signature, you can have different implementations. You can have the same function to different tasks in different classes. What is the significance of an abstract base class? An abstract base class is one which holds the pure virtual function. So, that particular function will have no definition in the abstract base class. Only those classes which inherit from this abstract base class will give a definition for those pure virtual functions, and you cannot create any object for this abstract base class. When do we use the keyword friend? The keyword friend is used to declare classes and functions when we want them to overcome the limitations of the access specifiers private and protected. So, when you call a class to be a friend or a function to be a friend, it has access, special access privileges to access the private and protected members of another class of which it is a friend. How do we declare a pure virtual function? You use the keyword virtual, the return type, the name of the function followed by brackets, and you equate it to 0. Only then it becomes a pure virtual function. So, these are the advanced concepts in C++ which gives programmers a higher level of programming capacity to overcome the limitations that are posed by the normal programming procedures. Thank you.